In match problem 1, we want to take a look at applying the marginal cost function, coming up with some results, and also providing an interpretation for what that result means. So the company manufactures automatic transmissions, and we're given the cost function for producing X items each week. We want to first find the marginal cost function. So again, marginal cost, marginal revenue, marginal profit. It's just the derivative of that original function. So 50,000 is a constant, that derivative is 0. 600x, the derivative is 600. And the derivative of negative 0.75x squared will become minus 1.5x. So for part B, we want to find the marginal cost at a production level of 200 transmissions per week. So we're going to take that value for x, a production level of 200, and plug it into our marginal cost function. Which in this case is going to give us $300. So what that means, if we just interpreted that into plain English, we're saying that at a production level of 200 transmissions per week, we know that our total production costs are increasing at a rate of $300 per transmission. Or another similar way to say that would be if we increase production from 200 to 201 units, our total cost would increase by about $300. It's costing us $300 to produce that next item. And then in part D, we want to find the exact cost of producing the 201st transmission. So C of 201 is the cost of producing 201 transmissions. If we subtract out the cost of producing the first 200, we're left with just the cost of producing that 201st item, which in this case will be $299.25, which again we can see is very closely approximately equal to that marginal cost at a production level of 200. So our estimate tells us it costs us $300 more to produce that next item. The exact cost is $299.25. So again, we're coming up with that very precise estimate for what's going to happen to our costs if we increase production by one more unit per week.